All right, so in this video, this is kind of just a check to see how you did on how you understood the triangle proofs using side, 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 and side angle side. So what I want you to do is I want you to pause the video, work through these, and then come back and check your answers when you're done. So, and hopefully you remember and retain a lot of the information we got from our last lesson. So let's see how you did. State whether the triangles will be proven congruent, if possible, by side, 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 or side angle side. Include a congruency statement for all congruent triangles. So your congruency statement may be different than mine. As long as the correct angles match up with the correct angle, or the letters match up with the correct letters, then you're good. So this one, you'll notice we have a side here, we have an angle here, we have a side here. The angle is touching the two sides. So this would be by side angle side. So if the other triangle matches it as well, it would be congruent. So side, angle, and side. So they do match up, so it's congruent by side angle side. And we'd say triangle QYT congruent to triangle CKP. So what I did is I just matched up corresponding parts, and since sometimes it's hard to tell with only certain information, okay, so you can kind of look to see which angles kind of look the same. But one thing you'll notice here is Q is across from side 2, okay? So I went from here to Y, which is an angle we knew congruent, and then that would be the third angle, QYT. So the angle across from side 2 on the right triangle would be C. So I start with C, so I start with Q. You can always go back and fill these in and help like mark things congruent so you know which sides go together and which angles. But so I went from C to K to P. So let's look at this next one here. So we know we have a side congruent to a side and a side, and then by the reflexive property, the third side is congruent to itself. So this is by side, 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 and we have triangle DAC congruent to triangle BCA. Now this one here, because they're overlapping triangles here, the order is going to be kind of reversed. So I knew D and B would go together. The one's furthest out. They're both across from side 3. So the next one here, I went to A, the one across from side 2 in the triangle on the bottom left. So that means it would go from A then to C. But over here, if I go across to the angle across from side 2, that would be going from B to C. Okay, and because if you look, this would be side 2 right here. So if I go across here, that would be A. For side 2 here, going across, that would be C. So because they're flip-flopped, this is when our order is reversed. And so BCA would be the correct congruent. Now, this one here, they're overlapping triangles here, but we can still determine some information here. And it's going to be side. We have an angle measure here at M, and we have a side, MK, is the same in both triangles. It's shared by both, so that means it's another side congruent. So we have side, angle, and then side on this one. So this is by side angle side, so we say triangle JMK congruent to triangle LKM. So make sure that these match up. The next one here, we have a side, we have an angle, and we have a side way over here. Notice this angle does not touch this side. So therefore, it is not one of our triangle congruences. So we say this is not congruent. Same thing over here, side, angle, and this side here. The side is not in between, or the angle is not between the two sides, so it's not congruent. So this one, number 5, you should have gotten side, 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 because we have a side, congruent to a side and a side, and the third side by the reflexive property gives us side, side, side. So triangle ECF is congruent to triangle EDF. And this one here, we have parallel lines and congruent. So we have a side here, congruent to a side here. We have a side here, congruent to a side here. Now, a lot of these problems can be done multiple ways, but one thing here is we're going to use, we're going to use our parallel lines here, which gives us JM as a transversal, which means that this angle will be congruent to this angle here, okay? But to prove this one congruent here, we want to go with the angle here, D, and the angle E in between here. So that gives us an angle in between the two sides. So we proved it by side angle side. Now, vertical angles are congruent here, but they would not help us prove this to be true. So it needs to be in a certain order. So side angle side is how we do this. So angle JAD is congruent to triangle MAE. And that's just, once again, matching up congruent parts. Corresponding parts as well. So here, this one here, we have a side, we have an angle here, we have a side, and the angle's not between the two sides, so this is not going to be congruent. In this problem here, we have, you should have gotten side angle side. We have a side here, side here, side here, side here, and by vertical angles, these two angles are the same. So we have the angle in between the two sides, so it's side angle side. So triangle ACB is congruent to triangle ECD. Now let's look at a proof. See how you did on your proof. So now, one thing you remember is that the order does not have to be the same as your neighbor, okay? You can get something else and still get the same correct reasons. It just may be in a different order, and that's fine. So typically we start with our given information. So AB congruent to CD, which is given. AB congruent to CD, which is also given. This is parallel. Okay, so we're going to mark these things over here. We mark them parallel and congruent here. Now, it says DB is the midpoint of BE. So we have all those three parts given. So what does it mean to be the midpoint? Well, that means that these two sides are going to be the same. Okay, so that means that BD is going to be the same thing as DE. Now, by the definition of midpoint. So we have a side and a side here. I mark both these. We have two sides proved. Now we need either an angle or another side. And notice here, by giving us parallel lines, we have BE acts as a transversal, which means we have a pair of corresponding angles. So angle ABD is congruent to angle CDE, and that is by corresponding angles theorem. And now we have a side angle side, which means we can now prove it in that triangle ABD is congruent to triangle CDE. Now, notice here that as we proved them, they were not in the right order of side angle side, and that's okay, because remember, the order over here is not important. It matters how does it fall on the picture. Let's see how you did it for number 10. We have KM congruent to NM, which is given. LK congruent to LN, which is given. Now, we know LM is congruent to itself by the reflexive property. So that gives us three sides congruent to three sides, which gives us our two triangles congruent by side, side, side. Number 11, we have side AD congruent to side AB. That was given. AC bisects angle DAB, which was given. So what does that mean? Well, it means it splits it up into two congruent angles. So what are those angles? Well, we have DAC and angle BAC. Now, if you're ever not sure what goes together, use your congruency statement up here. Okay, your congruency statement is going to let you know which parts match up. So that's one way to do this real quick and easy. And then, so now we have that gives us an angle, and then we know that AC is congruent to itself by the reflexive property. And then we can now say that our triangle ADC is congruent to triangle ABC, and that is going to be by side angle side. And then the last one here, we have JM is congruent to NM, that was given. L is the midpoint of JN, which is given. And JL is congruent to NL, which is by the definition of midpoint. Okay? Because remember, if it's in the middle, it breaks two things apart, so we have two congruent halves. So we need to be able to name those. So LM or JL congruent to NL. And then the number 4 here, LM congruent to itself by the reflexive property, which gives us three sides congruent to three sides. So triangle JLM is congruent to triangle NLM by side, side, side. So hopefully you did pretty well. Remember, when you're starting these proofs, you can always pick the given information. You can always get that part down. So remember, if it's up here in our statements, it's always going to be given. Consider our given information. We don't have to know much about it. We just have to know how to. We just need to know that's the reason. Now remember, definitions like the midpoint, you need to know what that means, or bisect. So, because what that tells us, we have two congruent parts. All right, so that concludes this page here. And now we'll go on to our next lesson, which is where we're going to learn how to prove triangles congruent by angle, side angle, and angle, angle, side.